Hi, welcome to my channel. In this video, I am going to discuss about the KNN classifier with a simple example. Now, KNN classifier here in this example contains, we are giving a new data point, new observed data point is x equal to 6, 8 and the nearest neighbors are equal to 3. Now we are going to assign the class label for this data point based on the observed data point. So whether the class label may be either pass or fail, okay, based on the actual data. So this is done by using some KNN classifier. Okay, here the class label, the actual data contains A1, A2, two features are there and the corresponding to class labels are there. Okay, now here these are called as the given actual data is called as contains mathematics and the corresponding computer science subject, and the corresponding results are nothing but a fail or pass based on these marks. Now they are giving the new data point that is called as x equal to 6, 8 and the number of neighbors are equal to k equal to 3. Based on this information, we are going to find out the class label, whether it may be a pass or fail. Okay, so this is we are going to assign this class label based on some similarity. Here we are going to use the class model called as a KNN classifier. The number of neighbors are equal to here 3, and it is depends on the some similarity measure. The similarity measure. What is the similarity? Okay, based on similarity measure, we are going to assign the class label here. So here the similarity is going to be nothing but a distance between the. We are going to find the similarity based on this distance between the actual value and observed values. Okay, so based on this information, okay, we are going to find out the similarity. Similarity is nothing but a distance between the actual value and the observed value. So here we are going to use there are different types of distance measures are there, like Euclidean distance, Manhattan distance. Like that we are having the different similarity measures are there. But here we are going to use the Euclidean distance as a one similarity measure. Based on this Euclidean distance, we are finding the similarity. Okay, similarity between the observed value, and the actual values. Okay, based on that information, we are going to assign the class label, whether it is a pass or fail. Now, here the similarity measure is a Euclidean distance. So here the observed value equal to, these are observed values. Okay, that is equal to 6, 8, and these are called as a actual values. The actual values contains two features, so that is the A1 and A2 and the corresponding class label. Here the number of instances are 5 instances are there. So now the similarity measure distance D is calculated as a D equal to square root of x first observed value minus the first actual value whole square plus second observed value minus second actual value whole square. Simply this is gives the similarity measure. Okay, now here we are going to find out the first similarity between the actual value versus observed value. Now initially we are having the observed value equal to the first observed value and first actual values are here. The actual value is observed value equal to 6, 8, and the first actual value is 4, 3. We are going to find out the similarity between these 2 points. Okay, we are going to find out the similarity between 6, 8 and 4, 3. Now here D1 equal to square root of observed value of first value minus actual value of first one. Okay, that is 6 minus 4 whole square. The actual value, the observed value of first value minus the actual value of second one, that is 8 minus 3 whole square, that is equal to square root of 2 square plus 5 square equal to square root of 29, that is equal to 5.38. Then we are going to find out the similarity between the second observed value 6 comma 8 and the corresponding the second row instance value, that is equal to 6 comma 7 whole square, 6 comma 7. Now here the formula is okay, d2 equal to the first observed value equal to 6 minus the actual value of the first value 6, that is 6 minus 6 whole square, plus the first the second observed value is equal to 8 minus the second actual value is 7, that is 8 minus 7 whole square, that is equal to square root of 0 square, the 0 square plus 1 square, that is equal to square root of 1. Okay, the output equal to 1. Then we are going to find out the similarity between the observed value is 6 comma 8 and the corresponding the third row index value, that is the actual values of 7 comma 8. Okay, now that means 6 minus 7 whole square, 6 minus 7 whole square plus 8 minus 8 whole square, that is equal to square root of 1 square plus 0 square, that is equal to square root of 1, that value equal to 1. Then we are going to find out the similarity between the 6 comma 8, the observed value equal to 6 comma 8. Okay, the fourth actual value is 5 comma 5, 5 comma 5. So that means the 6 minus square root of 6 minus 5 whole square plus 8 minus 5 whole square, that is equal to square root of 1 square plus 3 square equal to square root of 10, that is equal to 3.16. Then we are going to find out the similarity between the observed value 6 comma 8 and the actual values of 5th instance, that is 8 comma 8, 8 comma 8. So we are going to find out the distance between these 2 points. That means square root of 6 minus 8 whole square plus 8 minus 8 whole square, that is equal to square root of 2 square plus 0 square, that is equal to square root of 4, that is equal to 2. Now based on this information, we are going to find out, we are going to sort all the distances in ascending order. So in that we are going to ascending the order in the form of a 1, the first in ascending order 1, and that means smallest distance to largest distance, 1 followed by 1 and followed by 2 and followed by 3.16 and followed by 5.38. Okay, these are the order in which we are assigning all the smallest distance to largest distances. Okay, here the number of neighbors are equal to k equal to 3. That means here we are going to after ascending the distance in ascending order, you have to select that the neighbors are equal to 3. The neighbors are equal to 3. So these three distances are 1, 1 and 2. 1, 1 and 2. Now we are going to find out what is the distance, what is the corresponding index of value of the corresponding things. Okay. So here the one is nothing but this one. One is nothing but the first one is coming from the observed value to second index values. Okay, and the second one value coming from the the third index value. Okay, and then second the third smallest value is coming from the fifth index value. Okay, so that means 2, 3, 5. That means 2, 3, 5 are the index values of the data set. From that we are going to get the class labels are P, P, P. That means 3 P's are there. Okay, so here the majority class is P only. So here the majority class is P only. So then the class name for the new data point is also the data points also with k equal to 3R is also the pass class only. Okay, like that we are going to find out the assign the class level for the given data set. Simply this is called as a KNN classifier. Thank you for watching our video. Thank you.